So one little thing, when you have a rotating system, there really are two different directions that are useful to talk about. There is, here I'm trying to do this, there we go. There's the radial direction, which is just in the line with the radius. And then, of course, there's tangential. And we already have a formula for the tangential acceleration, and that is just that it's the angular velocity. Remember, that has to be in radians per second squared, right? It has to be all radians. But if you multiply that by the radius, you get the tangential acceleration, okay? Radial acceleration, if you recall, is actually just opposite the direction of centripetal acceleration, okay? So centripetal acceleration, if you recall, means toward the center. So anyway, so they're parallel to each other, okay? So let's look at centripetal acceleration in a rotating frame of reference, right? So we got two formulas. We've got our friend, the v squared over r, then we've got v is omega r. To make that a rotational formula, all we do is we just substitute, right? So centripetal acceleration is v squared over r, which means it's omega r, which is, this is our tangential relationship, right? The tangential velocity is just omega r. Remember, this has to be radians per second, okay? So this squared, right, over r. Well, omega r squared is what omega squared r squared divided by r becomes, there it is, okay, is omega squared r. So that is our formula, right? Okay. So this is just our radius. That's going to be in meters. This is our angular velocity. It has to be radians per second. Can't be rotations per second, can't be RPMs, can't be anything else, okay? Now, just, I feel like I should point this out, so I'm gonna. Okay, take a look at the data packet. These are the formulas they give us, and this is in section 6.1 of the data packet, right? They give us v squared over r. They don't actually, I think maybe that formula is in there somewhere, the omega squared r, but here it is, right? This is, in my opinion, this is badly done, right? They should have m 4 pi squared r over t squared, right? And then here they should say equals omega squared r, right? Here, let's fix it for them. m 4 pi squared r over t squared equals m omega squared r. This is, in my opinion, this is how they should have done the data packet, but they didn't. Okay, but that's not my point here. My point is, take a look at this. Take a look at this formula right here. Okay. Okay, what is 4 pi squared over t squared? Remember, omega is 2 pi over t, over the period, yeah? Okay, omega is 2 pi over the t, because it's, let's say your period's 1 second, right? Then you're doing 2 pi radians in 1 second, 2 pi, 6.28 radians per second, okay? So isn't this just omega squared? That's fun, right? So basically, 4 pi squared is omega squared. 4 pi squared over t squared is omega squared times r. It's the same formula, you know, there it is. All right, so let's look at our example here. We're just going to use this. We're going to use centripetal acceleration is omega squared r, only we have to turn this into radians per second, okay? And then we can use it, right? So 10,000 rev per minute multiplied by 2 pi rad per rev, right? That's how many radians there are per revolution. And 1 minute is 60 seconds, right? So now we'll have radians per second. The old units will cancel. There we go. All right. So 10,000. Whoops. My calculator got so bored it shut itself off. 10,000 times 2 times pi divided by 60 is 1,047. Point about 2, right? I'm not going to actually round this number. That's radians per second. So this equals 1047.2 squared times, and then 5 centimeters. Don't be fooled by centimeters, right? So 0.05 meters. Okay, so I'm going to square the number on my calculator times 0.05, and it's still a lot. I'm getting 54,831 meters per second squared. Notice that this is radians per second. When you square per second, you get per second squared. So the units all work out. All right. That's all I have to say about that.